and welcome back to another exciting episode of the Athero Talk podcast, the series brought to you by the EAS Young Fellows. I'm Azin Khairkha from the Institute of Genetic Epidemiology at the Medical University of Innsbruck, and I'll be your host for today. Before we dive in, I want to take a moment to sincerely thank you all for your support. As newcomers to the podcasting world, your engagement means the world to us. We would love to hear your feedback and suggestions, and it's the best way for us to grow and shape this podcast into something you truly enjoy. So don't hesitate to reach out. In this episode, we have the pleasure of welcoming Professor Florian Kronenberg to the podcast. Professor Kronenberg is a full professor and the head of the Institute of Genetic Epidemiology at the Medical University of Innsbruck. His research focuses on genetic and clinical epidemiological studies of lipoprotein a. He is the deputy editor-in-chief of the Atherosclerosis Journal and has contributed to multiple guidelines and consensus initiatives. And as many of you know, his latest contribution was in the EAS Consensus Statement on Lp(a). This interview is personally special to me as Professor Kronenberg supervised me during my PhD, and I still have the pleasure of working closely with him. So hello, Professor Kronenberg. On behalf of the EAS Young Fellows, I want to thank you for accepting our invitation. Your impressive career is difficult to summarize in just a few sentences. Would you say this introduction captures your work and who you are, or is there something you would like to add?
Yeah, first of all, I would like to thank you for this possibility to talk to young fellows. I think young fellows are our future, and therefore it's really important to talk to them. But I think you summarized very well what my career was.
Thanks a lot. So in our interview so far, we begin with personal questions before transitioning into research-focused questions. So to start, how would you briefly describe a typical day in your life?
Usually I stand up quite early. Sometimes I start to work already from home, and after breakfast I'm going to the institute, and most of the time I'm overloaded with work, and I will have to find ways how I can accomplish it. But there are very different tasks, and this makes it really interesting. Preparing lots of talks, talk to other people, have many video conferences, discussing ideas, meet with people from the institute. So I'm not lonesome.
Yes, this is a very packed schedule with so many tasks of different things. And how do you manage to balance your professional and personal life?
I'm not sure whether I can balance it. I simply try to convince me that I'm balancing my life. But I think the most important thing is that you are really addicted to your work, and then it's no longer such a big issue what is work-life balance, because there's not really a really clear-cut difference between life and work. So I have no troubles with that.
That's amazing. And so as I can see, your work is also sort of your hobby as well. So you really love it. And do you have other hobbies that you do alongside work to sort of, relax a little bit and to give it a different change?
Yeah, I think to escape the rest of the world is for me to make ceramics. And yesterday I ordered a new oven to burn the ceramics up to more than 1250 degrees of Celsius. So this is something where I can escape and where I can build something, I can sculpture something. This is something which makes a lot of fun to me. The other part is we have a house, we have a garden, and you can see me running around with a chainsaw to cut the trees and all the stuff, repair things. So I really like that. Mm-hmm. This is giving me balance.
Yeah, I think this is amazing. So connecting to nature and also doing something with your hands and building an art, it's beautiful. It's the same. It's interesting that I also started ceramics recently, so I really enjoy it as well. So could you tell us about your academic journey and what led you to where you are now?
Yeah, I think this was not completely planned in a structured way. One of the rules, when I look back now, it came always different than I would have planned or expected. But I think one of the big learnings from that is that you have to be open. That you have to be open for new turnings. Yeah, you are coming to a crossing and you do not know where go to the left or to the right, and there are windows of opportunities, and to take those windows of opportunity. And I think when I started out in med school, I wanted to become a surgeon, especially in neurology. But then I met people working in nephrology, and I thought, oh, maybe that's a good idea to work in that area. And then I did also my MD thesis in nephrology. And then I came to the Institute of Gerd Uttermann and Hans Dipplinger and realized what's going on in research. And I had my first research project, and I became addicted to that. And then all of a sudden I didn't want to become anymore a nephrologist and wanted to stay in research. And there were many situations in my life where at the first glance, there were situations I didn't really like, but nevertheless I took it, and then it turned out it was wonderful. So
that's really great to hear, especially for young researchers, to know that it's not a linear path and everything can change in between. So you wanted to be an MD, a surgeon, and then it totally changed, and it's interesting.
Yeah, I think that's extremely important, that you are open. You have to find your niche, of course, and but this openness allows that other doors are opening, and all of a sudden, yeah, it's wonderful.
Yeah, and it's like taking the chances whenever
Yes.
there is a new opportunity.
Yeah.
That's very important. And so talking about niche, so everyone knows you on Lp(a) research. What happened that you chose this Lp(a) over all the other lipids, and how did you become so focused on this? Can you tell us about the story of this?
Yeah, I think this is, as almost everything in life, it depends on people. It depends on other people. For example, when I came to Hans Dipplinger and Gerd Uttermann, of course, the main topic to work on was their Lp(a). And so this became a fascinating issue to me. And I never left that area. I touched also other areas, but this is my real life, you could say. But I met also other people like Roger Williams. Roger Williams in Salt Lake City. I had the pleasure to work there for 2 years, and Roger Williams was an absolutely enthusiastic person. He was the founder of the MedBed program. This stands for Make Early Diagnosis, Prevent Early Deaths. And you have to keep in mind, 30, 40 years ago, there were so many people, they did not get treatment because of their high cholesterol. And the idea of Roger Williams was to identify each person in the world suffering from familial hypercholesterolemia. I did not understand why he's doing that, but then he told me sometimes the story that he had a family when the first time was arrived that statins became available. Till that time, those people who had this familial hypercholesterolemia, they did not have a chance to get it lowered. And he was a Mormon, and for Mormons, families are really important. And he told me that a family approached him where a person in the age of 55 said to him, "You made it possible, or the statins made it possible that I can hold my grandkids in my arm," which is really important for a Mormon, to have the family. And this was really, then I understood why he wanted to diagnose everybody who has familial hypercholesterolemia and to get them a treatment. And I think this was something which reminds me to my situation now, that I'm also very much interested that everyone who has very high Lp(a) concentrations is identified and gets the best treatment as possible.
That's amazing, and it's a motivation to run this research even further. So, Florian, you've been involved in many guidelines and consensus initiatives, and most recently the EAS Consensus Statement on Lp(a). Could you share with our listeners what it takes to be part of such big projects, and what was your first experience like, and what key lessons did you take away from the process?
Yeah, I think this started already more than 20 years ago, where I was involved in the KDOQI guidelines. These are guidelines which are for kidney patients. And I had published at that time already a couple of papers in the area of kidney patients. These were mostly epidemiological studies. And then the group approached me whether I could be part of this guideline group to make new guidelines. And this was a really interesting approach, and it's completely different to nowadays approaches, because we were working on these guidelines for more than 2 years. Yeah? And we really worked very hard when we put together every evidence which was available at that moment. Nowadays, everything is much faster. To working in such guideline groups or consensus groups, you have really to listen also to other people to understand what their approach is, what their opinion is, what their evidence is, and bring everything together. And then you have to find a conclusion where everybody can agree on. And I think this is always an interesting way till you get the consensus. And but when you have the consensus, you are quite happy about that.
Yes. And coming back to the EAS Consensus Statement on Lp(a), how do you see these consensus papers impacting researchers and clinicians in the field?
I think, first of all, it was very important to have a group, a panel, where I knew that they are all experts in the field, that they are all persons I can trust. And together with Samir Mora and Eric Strös, it was really great to head this group and bring all the knowledge together. Now we have the consensus here. We see that it is changing the real life. A lot of research started on that. Of course, it's also driven by the fact that medications are already in phase 3 trials to lower Lp(a) concentration. But this was only touched very minimally in the consensus statement. It was more on what we can do already for people now when they have elevated Lp(a) concentrations. Why is it really important to identify those people and to tell them what they can do now? So if a person has, for example, very high Lp(a) concentration, then you can offer them something. You can offer them, now let's look at your other risk factors, make a global risk assessment for this individual. And when you identify risk factors, then make a management program for them. And I think this is really important because you have to give them somehow a possibility how they can handle that. And of course, since the Lp(a) concentrations are so strongly genetically determined, Lp(a) is not simply an individual issue. It's a family issue. It's a family condition. Therefore, the family is also very important. If you identify a person with high Lp(a) concentration, you should also be interested in the other family members, because that person which is sitting in front of you might be fine. Also, the high Lp(a) concentrations are available, but no other risk factors. But that person might have family members who have also high Lp(a) concentration and other risk factors which should be treated. Therefore, you should never see first Lp(a) alone, second, see it always in context with the other risk factors, and third, look at the family. And then you have possibilities how to handle the situation. Give advice to the patient or subject or the family.
Yeah, that's very important. And so Are there any misconceptions about Lp(a) that you often encounter among clinicians or researchers or even patients? And for instance, are there confusions with Lp(a) threshold levels, for instance?
Yeah, I think one of the biggest misconception is, and what I hear very often, why should I measure Lp(a) when I cannot yet lower it? We know that we will have drugs available in the future, and hopefully they will also decrease the cardiovascular events, because only then a drug is interesting, when it's not only lowering Lp(a) but also lowering the cardiovascular events. So, but I think this was the main part of the consensus paper, that we said clearly what we can already do now. So treating the other risk factors and all this stuff, give very clear advice on that, make good tools for global risk assessment. So Brian Ferentz wonderfully presented a risk calculator where Lp(a) is included. So this is extremely helpful. So we can already act now. Therefore, we can clearly say this is one of the misconceptions where we can clearly say we can act already now. This is one of the biggest misconceptions. Another point is people, and especially physicians, are always thinking in thresholds. And in Lp(a), we do not really have a threshold. We can clearly see the higher the concentration, the higher is the risk. But clinicians want to have thresholds, and we have to help them somehow. And many use this threshold of 50 milligram per deciliter or 125 nanomoles per liter. But if people have concentrations above this threshold, there is a difference whether someone has 60 or 200 milligram per deciliter. And we have to teach the people that they should not only look whether someone is above a threshold, because it's a continuous relationship.
Yeah. Thanks. And if there is one key message you would like clinicians and the general public to understand about Lp(a), what would that be?
Yeah, it's a very important risk factor. It's an independent risk factor. So if you do not measure it, you will not get the information which is sticking in the Lp(a) concentration. We have also very clear evidence that this is a causal risk factor, and therefore it's very important to make a global risk assessment for a given person. But this was not only one message I gave you now.
Yeah, exactly. That's nice. We have several messages now. So you're also an expert in the field of nephrology-related dyslipidemia. What are the current insights into the role of Lp(a) and CKD, chronic kidney diseases?
Yeah, first, we know already a very long time that the kidney seems to play an important role in Lp(a) metabolism. We know that with decreasing kidney function, the Lp(a) concentrations are increasing. And this is not only driven by the glomerular filtration rate, especially albuminuria is here really important. And we can see, for example, in people who have a nephrotic syndrome, where people lose a lot of proteins in the urine, they have dramatically increased Lp(a) concentrations. So this is the condition with the highest Lp(a) concentrations. That the kidney plays a role somehow, we learned that already more than 20 years ago when we measured the Lp(a) concentration in the renal vein and compared it to the renal artery. We see lower levels in the renal vein, and we did a lot of control experiments. We still do not understand why this is the case. We see in urine that we can find fragments from apolipoprotein a, from the apolipoprotein, but we do not really understand the role what the kidney has. It's one of the, we call it the secondary conditions of an Lp(a) elevation, and it's probably one of the most prominent ones. And we, of course, we know that also in this kind of high-risk population, Lp(a) is an independent and important risk factor for cardiovascular disease.
Yeah. That's good to know. And we're seeing exciting developments in the Lp(a) lowering therapies. How do you see these shaping cardiovascular prevention strategies, and could patients with CKD that you just mentioned also benefit from them?
Yeah, first of all, these drugs are really exciting when we see that they can lower Lp(a) concentrations up to 99%. So Lp(a) is almost eradicated, you could say. This is amazing, but the most important piece in the puzzle is now that we see whether lowering Lp(a), the specific lowering of Lp(a), lowers also the cardiovascular event rate. If that is shown, this is great, but then these medications will become available only in secondary prevention. That means if someone has already experienced a cardiovascular event. I think it will be a further journey to get these drugs become available in primary prevention. And now then we are really talking about prevention. We would like to avoid the first event. And for that, we will need studies also in the primary prevention setting, which are you have to include more patients, long observation periods. So this will be a long journey, but it's an interesting journey. And I think I'm very convinced that this is really the next target we have to fight in cardiovascular disease. Besides LDL lowering, Lp(a) lowering will be important. Inflammation, of course, is important, but this is also somehow related, because when we have high Lp(a) concentration, then this triggers inflammation in the arterial wall. So this will become really interesting, and also in the CKD population. But there we will have to wait for studies, because the CKD population is often a group of patients. Also, it's high risk. They are often not included in the typical clinical trials. And I'm curious whether any of those companies will go out and test such medications also in a patient group like chronic kidney disease.
Yeah. This would be a long journey, but a promising one, hopefully. And since we're talking about future perspectives, could genetic screening of Lp(a) become part of routine cardiovascular risk assessment, especially in high-risk populations?
Yeah. I think the genetic screening in terms of Lp(a) does not have a role in clinical practice, because the genetic regulation of the Lp(a) concentration is so complicated. It's not enough to simply genotype 2 or 3 SNPs or something like that. There's such a strong interplay between the SNPs, as well as between this copy number with this crynil 4 type 2 repeat number. Such a strong interplay that you will not get the information simply from genotyping a few SNPs. And people have to know that because there are offers out there from labs which offer genotyping of 2 famous SNPs, but this is not enough. It's much better to measure Lp(a) concentration, and this was also a recommendation we have given in the EAS Consensus paper, that the information which is sticking in the Lp(a) concentration is much more comprehensive than genotyping a few SNPs. Mm-hmm. So it has, in usual clinical practice, it doesn't have a place. And there are some exceptions where it might become interesting to do that, but in the usual daily practice, there's no sense for that.
Okay, thanks. That's also very important to know. Are there some new projects on Lp(a) that you are currently working on? Some big questions, important questions that you want to address with your new research that you would like to share with our listeners?
I think one of the really important questions which I'm not able to answer is, what is Lp(a) good for? Mm-hmm. Because why was it invented in the evolution? We have till now we have no clue for what is it good. So, but this will not be a research topic of our group. But I think the new projects on Lp(a), of course, is how can we better understand the genetic regulation of the Lp(a) concentration? But this is from a scientific point of view, not from a clinical point of view. So this is something which we are dealing with in our institute here. And the other thing is, or 2 other things which are somehow related. We have created the International Task Force for Lp(a). This is coming from out from a patient organization from FH Europe, and our goal is to develop a roadmap that everybody who wants it can get an LPA test, and depending on the result, that people are treated appropriately. And this not only starts when we have LPA-lowering drugs available, as I told you before, this is also management of the global risk of a given person. And this international task force is at the moment extremely active. We are planning in March a global summit on LPA, which will be in Brussels. It's only by invitation, and we bring together key opinion leaders worldwide and also people from the patient organization, and we'll bring them together also with politicians who are making then finally decisions what should be done. But we will prepare what we think as a task force would be important for individuals and patients. And in context with that, we have a project running which is dealing with the cost effectiveness of LPA measurement. And that means we bring numbers which clearly show that in high-income countries, as we have it in Europe here, or United States or Australia and so on, it's quite cost-effective to measure LPA when you take the consequences in terms of if someone has high LPA concentrations, then you should also follow what is recommended to bring down the other risk factors. And by avoiding heart attacks, ischemic strokes and all this stuff, you can save a lot of money, and you save more money than the costs are caused by the measurement of LPA. Even if you measure it in everybody at least once, you can save costs by that when you take the consequences, in the sense that you are treating the other risk factors more intensively as you would do it without knowing the LPA concentration.
Thank you, Florian, for telling us about this LPA Global Summit in 2025. And so how do you envision the future of genetic epidemiology? Are you already implementing new strategies at your own institute to adapt to emerging trends? Additionally, what advice would you offer to researchers and professionals in this evolving field?
When I look at our institute here in Innsbruck, I would say we are not a typical institute of genetic epidemiology, because we have different pillars in our institute. We have on the one hand, we have a protein lab where we are measuring LPA, also other lipoproteins, other proteins. We have on the other hand the genetic lab where we are doing genotyping, we are doing sequencing, and most of all, very important is that we try to elucidate this very dark region of the LPA gene, which is, we call it always a camouflage gene, because of this complex structure where it's almost impossible to get the complete sequence, and there's a lot of information is hidden in this sequence, and therefore we are very much interested in that area. But to do that, it became extremely important for us to have also the informatics support here, and we started already probably 15 years ago to bring in a completely different discipline, namely informaticians. They came in and we made them the geneticists, and now they are making wonderful tools for the elucidation of this complex gene region. Besides that, we have also very strong statistical support here in the Institute, which is a common situation in genetic epidemiology. So that means we are genetic epidemiology with genetic lab, protein lab, informatician lab, and also statistical lab. So this is, I think, something which is very unusual, and this is has to deal with the situation that we are so much focused on a certain protein, on a certain lipoprotein. And I think also in the future the elucidation of complex diseases, for example, polygenic risk scores will become very important. We have a long way to go here to bring it to clinical practice. You have always to see that all the things take a long time till they come into the clinic. So we were talking already in the 1990s about LPLA, and in the clinical context, we recommend LPLA measurement already a long time. Now it takes up speed because of these drugs which are in development. And more and more people get an LPLA measurement. And when we are talking about polygenic risk scores, of course, we have to develop tools that the physician can really use that, so that nobody will sit down and calculate the polygenic risk score when they are sitting in the clinic in front of a patient. So they have to. We have to provide them tools before we can really use it in clinical practice, and we have to learn much more about it, how to create really a good working polygenic risk score. And many people in the world are working on that.
Yeah. And so would you say that one of the reasons for this success in this institute is because of the interdisciplinary collaboration between the different fields, and that's an important thing to bring the success?
Yes, I'm strongly convinced about this. We have people in our institute who are, where the goal is that everybody stands for something, where they become experts in the field. And my goal is, when I'm retiring, that all of the people in the institute are much more smart than I, that they have developed their own research area, that they are known for something. I think that's very important to allow people this development. Of course, at the moment, when it has to do with LPLA and in clinical practice, since I'm the only medical doctor in the institute, of course, I'm going out with this information, but I can only do this because of these people here in the institute who are making this really important work to bring the field forward.
Thank you, Florian. So in our interview series, we have a section dedicated to failures, and we call it the Graveyard of Ideas, where researchers share a story of failure in their career. Most of the time, we hear success stories, which makes some of us question ourselves. So we want all researchers to know that failure is part of the process. And so do you have a story for us to describe?
Yeah, but then I have to go back very wide in my back in my development. I was supposed to become a priest, and I failed. I did not become a priest, and nowadays.
I think this would be a shock to all our listeners listening to this story.
But anyway, I did not become a priest, and studied medicine, and now working in the field. But now it reminds me a little bit what would have been my job as a priest, namely preaching. What I'm doing now is preaching about LPLA. I'm giving so many talks about LPLA, and I still like to do that because I would want to bring out the message. And this is, as a priest, I'm preaching.
So it turned out to a success anyways.
Yeah, the failure turned out 50 years later as a success.
And do you have any advice to young researchers?
Not only one advice. I have many advices. The first one is be open. You can, everything what you are planning will develop differently if you are open, and in most of the times it's much better than you would have expected. So therefore, be open. The next recommendation I have, be on fire. Become addicted what you are doing in your research, because only when you are on fire, you can search for new ideas, you can search for new findings. This is really important. The other one is be friendly and share. Because only when you are friendly and sharing, then also other people will be friendly to you and share with you. And Yeah, and also enjoy the success of others, of your peers, of your institute or your institution. I think it's very important that you can also enjoy the success of others.
Thank you. These are definitely important take-home messages for all young researchers.
And I feel again as a preacher.
Thank you, Florian. So before we conclude this interview, I have one final question that might also benefit the early career scientist. So earlier this year, you stepped into the role of Deputy Editor-in-Chief of Atherosclerosis, so congratulations.
Thank you.
And given your editorial experience, what key advice would you offer to researchers submitting to the journal? And what are the most common pitfalls they should be mindful of?
I think it's very important that you make science which not everybody is doing. So finding kind of a niche, which is important, of course, but where not everybody is on this topic, is important, and don't repeat too often the things which are done by others. So you should find also your own points of interest. And then when you have your results, and then when they are really good, then submit it to atherosclerosis. You are very welcome to do that and prepare a really good abstract where you really show what is the interesting part of these manuscripts. We get so many manuscripts where the abstract is often so badly written without any information, and then you go into the manuscript, and sometimes there's really wonderful information hidden there, but it's not really mirrored in the abstract. Yeah.
So the key message is that don't underestimate the abstract, the importance of it.
Yes, and make the story and the entire paper in a way that it doesn't look sloppy, and very well structured, so that you can really see, the reader can really see you are telling a story, and it makes the reader noisy to see what is now in the next chapter. I think that's extremely important.
Yeah.
And of course, the good results.
Yeah, exactly. So this was such an incredible interview. Thank you, Professor Kronenberg, for sharing your time and insights with us. Also, a big thank you to all our listeners. This podcast is for you, so please don't forget to leave us your impressions. We also hope to see as many of you in the upcoming EAS Congress in Glasgow. Again, thank you so much, Professor Kronenberg, for your time.
I think it was a pleasure for me.
Thank you.